Hi, Algebra 1 students. Welcome to today's lesson. Today we are going to be talking about ratios and proportions, as well as the percent of change. So please copy down our lesson objectives into your notes to compare ratios and solve proportions, and to find and solve the percent of change. So ratios. A ratio is a comparison of two numbers by division. It could also be thought of as a fraction or a rate. Ratios can take the form of x to y, which can also be written as x to y, or as a fraction, which is x over y. So these are different ways of representing ratios. Now let's look at proportions. So proportions are an equation stating that two ratios are equal. For example, we have our ratio here, AB, which is equal to ratio CD. So the total equation would be a proportion. I will talk more about this cross multiplication at the later slide. A few vocabulary terms to be aware of. When we talk about the means of proportions, we are talking about the inside two variables, which correspond to those two. And then the extremes are the outside two, which correspond to A and D. So make sure that you have those in your notes. So in summary, the product of the extremes is equal to the product of the means. So again, if we look here, we see that our extremes are A and D, and our means are B and C. And those two equal AD and BC. For example, if we have 2/4 is equal to 1/2. If we are to show our work, we get 4/2 is equal to 1/2. We can multiply first both sides by 2. We see that this 2 cancels out with the 2. And then we can multiply both sides by 4. We see that the 4 cancels out, so we get 2 times 2 is equal to 1 times 4, which is equal 4 is equal to 4, as shown here. So that is a summary on proportions. Next, I did want to talk about the cross product. So as this illustration shows, if we multiply D by both sides, we can cancel out D on this side, and then we multiply both sides by B. We can cross out B on this side, and we end up with this equation, AD, which can be thought of as our extremes. Remember, it is the outside two are our extremes, and the inside two terms are our means. So we have our means and our extremes. So let's look at the cross product of a few ratios. So let's determine whether each pair of ratios forms a proportion, meaning they are equal to each other. So first we have 2/3.5 is equal to 8/14. So again, we can multiply both sides by 14. So we're going to do our cross product. And we end up with 2 times 14 is equal to 8 times 3.5. Now we can evaluate that. 2 times 14 is equal to 28. And 8 times 3.5 is equal to 28. So it is a ratio. Now let's look at B, which states 15 over 36 is equal to 35 over 42. Again, we are going to use our cross product. And we end up with 15 times 42 is equal to 35 times 36. Now 15 times 42 is 630. And 35 times 36 is 1260. So this is not a proportion because the two ratios do not equal each other. Now let's look at an example. I'm going to skip this example, but let's look at this example over here, which says x minus 2 all over 14 is equal to 2 over 7. So now we need to solve for x. And in order to do that, we need to isolate x on one side of the equation. So first we're going to do our cross product like we did before, and we're going to end up with 7 times x minus 2 is equal to 14 times 2. Then we're going to do our distributive property. We're going to get 7x minus 14 is equal to 28. We're going to add 14 to both sides. 7x is equal to 42. And then we will divide by 7. We see that x is equal to 6. And again, we can check our answer by plugging our x value into our original equation. So we have x minus 2 over 14 is equal to 2 over 7. 6 minus 2 over 14 is equal to 2 over 7. 4 over 14 is equal to 2 over 7. And now we can do our cross product again. Or we could divide this side by 2. And we see that 2 over 7 equals 2 over 7. So this is how you would solve for x when we are comparing proportions. Now let's look at an example with x in the denominator. So we have 7 over x plus 9 is equal to 11 over 16. Again, like before, we're going to do our cross product. And we end up with 7 times 16 is equal to 11 times x plus 9. Now we are going to do our distributive property. Distribute 11 in. We get 7 times 16 is equal to 112. Is equal to 11x plus 99. We can subtract 99. We end up with 13 is equal to 11x. Divide by 11. we see that 13 over 11 is equal to x. We will check our answer by plugging it in to our equation. And we see that 7 over 13 is equal to 11 over 16. And when we simplify 7 over 13 elevenths plus 9, we end up with 11 over 16 is equal to 11 over 16. So that is how you would isolate a x in the denominator in a proportions example. So ratios can also be used to make a scale model. For example, you may have noticed in Google Maps scales their map, and you can see here they've scaled it. 500 meters represents this distance on the map. So you can use that as a reference. So ratios can be a scale model of something. When ratios of two measurements have different units, the measure is called a rate. For example, a price of $59.99 per 10 songs, if you were to buy that for that cost, is called a rate. So it is $59.99 per 10 songs. All right, a brain break for you all. Go ahead and read the cartoon at your leisure. Moving on to the next topic, we're going to be talking about percent of change. So percent of change is the ratio of the change in an amount to the original amount, often expressed as a percent. And what this means is we have our amount of change, so we determine that and we divide that by the original amount. We then will take this 100 and multiply it by that difference or that ratio, and we will get our percent of change. So our amount of change is going to be the new minus the old, and again in absolute value, so it will always be positive. If the new is greater than the old, then we will talk about the percent of increase, and if the new is less than the old, then we will talk about the percent of decrease. One thing to note, percentage of change is relative to the original amount. And what that means is the change in value is always divided by the original amount, as stated here. So make sure you have this formula. You can put this under the amount of change, have this in your notes. So let's look at a few examples together. So determine whether each percent of change is a percent of increase or a percent of decrease, and then find the percentage of change. So we have our original is 20 and our final is 23. So we're going to subtract the original amount from the final amount to find the amount change, which we see here is 3. Since the new amount is greater, as we talked about before, then this is going to be a percent increase. Next, we need to determine the percent of change. So we're going to use the original number as the base in our equation. So we know that our change is 3 and our original amount is 20. And then our percent change is going to be R over 100. Again, we're going to need our cross product. So we're going to cross. We see that 3 times 100 is equal to 20R. And then we're going to divide both sides by 20 to isolate our variable. We see that R is equal to 15, which means that our percent of increase is 15%. So let's look at one more example. So our original here in B is 25, and our final is 17. So this time, again, we subtract the original amount, and we find that is -8. So we see that the new amount is less, so we're looking at a percent decrease in this case. Percent of decrease. So again, we use our original number of 25 as the base. We put our -8 as the change. We do our cross product like we've been doing. We see that -800 is equal to 25R. We isolate R. We see that our change is 32 or -32, which means it's going to be a decrease of 32%. So this is what I'm expecting you to show for work when you are answering these kinds of questions. So let's look at another example of percent change. This time we're going to have a variable within it. So in this case, the total number of passengers on a cruise ship increased 10% from 2007 to 2009. If there were 17.22 million passengers in 2009, how many were there in 2007? So we're going to let F equal the number of passengers in 2007. Since 10% is a percent of increase, the number of passengers in 2007 is less than the number of passengers in 2009. So how would we go about solving that? We see here that our equation set up, we have our change is going to be 17.22, which is in millions because we are talking about 17.22 million passengers. Subtract F because F is the number of passengers in 2007. So that is the change. All divided by our original amount, which is F, is equal to 10, which is our 10% over 100. Again, we're going to do our cross product. So we're going to multiply 17, this should be 17.22 minus F times 100 is equal to 10F. We get 1722 is equal to 100F if we do our distribution property. And again, we're trying to isolate F. So we add 100F to both sides, and we get 1722 is equal to 110F. We divide both sides by 110, and we see that there were 15.65 million people that were on cruise ships in 2007. So that is how you'd go about solving a percent of change example that has a variable in it. So there are two assignments. It's 2-6 practice problems and 2-7. Those can be found under day 4, the ratios and proportions and percent of change page on PowerSchool Learning under the classwork tab. So for 2-6, you're going to be working on page 115 and 116 of your e-textbook, and the 2-7 worksheet can be viewed or downloaded from the classwork tab under day 4 on PowerSchool Learning. If you have questions, send Mr. Schuessler an email. Thanks for listening. Have a great rest of your day.